G'day, comrade subscribers. I don't know if I'll post this or if I can fix it, or if I do post it, I don't know if I'll notify everyone because, well, it's not a computer, is it? Well, it is. It's got a little computer in it. It's basically kitchen scales. I just use them for weighing packages and stuff. But it's been a while now. It's just not, so when you turn it on, you can see it kind of initializes, and sometimes it can't initialize, and sometimes, we're just jumping all over the place. Even when you try to zero it, we get negative gravity, so we get negative weights. So it's basically just a set of kitchen scales. It's got a port for a temperature probe as well. So it says here, engineered in Australia and made in China to our exact specifications. So it's quite old. I don't know, maybe it is 2016, or it could be 2013. So that could be the year it was made. So the last few years, it's just been doing that, which has been a bit annoying. So, but it's good enough just to get a general idea, but I just wish it would just stop doing that. So I was going to try and fix it a few months ago, and of course the bloody thing was just working perfectly. So I don't know I don't know if it's just because I don't know what's in it. So I don't know if there's just the mechanism just needs to be lubricated or reset or something. So I thought I'd do a video on it. Runs on a 9-volt battery in there. Yes, I have tried pulling the battery out and resetting it that way. Makes no difference. So I think it's more of a physical/mechanical issue. So I thought pull it apart, see how it works, and see if I can get it working again. Okay, so there were 3 obvious screws, which I've undone. And it does look like this metal strip has something to do with how it stays together. I don't know what that is. If I can peel it up. Okay, so that obviously would be screws for the weighing mechanism, I guess. I don't think that's going to pull it apart. So my other guess is that either it's all clipped together, or maybe there's some screws hidden under these feet perhaps. Let me just check out the feet. Yeah, there's a screw there. Alright, I'll continue trying to find the rest of the screws. I think I haven't pulled that one off. I assume there's no screw there. Okay, so that's loose. I don't know, does this... Maybe I do have to unscrew these to get this top thing off. Let's see. Maybe. Maybe. Okay. Yep, okay, that's off. Alright, that's pretty simple. That's all it was. Okay. Right. Okay, that comes off. Alright, buttons won't fall out. Very good. So, how does it work? Interesting. Doesn't seem to push down on anything because this metal thing is... How does it work? I know, I can probably just Google it. So that sits on there, that pushes... Huh. Interesting. I'm sure there'll be some principle to it. Right, well, does it work now that I've pulled it apart? Let's put the battery back on. And let's turn, I think that one's power. Okay. Thinking about it. So this is sometimes what it does. Yeah, okay. Does that as well. Nope. Okay, yep, still not working. So, question is, I guess I just want to pull this apart, don't I? All right, let me get. All right, let me pull this off. Okay, I've pulled it out, so it's actually a four-way wire, and we've got V plus, S plus, S minus, and V minus. So I'm assuming plus minus voltage and plus minus for the sensor, blue and white for the sensor. So it runs into the side here, and it looks like it comes up to here. Now the actual plate, let me grab the plate, doesn't look like it actually touches. I'll try and do this. So the actual plate, like that. Let me just do this, I'll come back I think. So that's how it sits. But yeah, there's a sensor there and there's, I assume, the same underneath. So it's just a, I don't know. It sits, it presses down or something? I just don't see how it works. But I guess I could try and check the voltages on that. Okay, I had a quick look how it works. Strain gauge technology. So this is a transducer beam. Because I was having a fiddle with it. So if we power it back on again, there's basically a sensor on both sides. Okay, trying to initialize. No, okay, couldn't initialize. So we've got four wires in, we've got, I guess, plus or minus voltage, and we've got plus or minus sensor. And from those wires, we've got quite thin wires going off both sides. So it normally sits like that. And when it was working, let me try and get it on again. Let me just put it on its side, perhaps. Let's see if it's going to be happy this time. Okay, it looks better this time. Now that I've taken it out, it seems more stable. But no, it doesn't look okay. You see, it's kind of more stable now. It's still going off, but so the way it works is so that's the way it is. So that's the top, that's the bottom, and can I, as I say, use the 9-volt battery to lift it up a bit? Maybe use the, there we go. Can we see the screen now? All right, now let me set this up properly. Let's use the battery after all. So what we've got, yeah, it goes in like that. Get my finger out of the way. Oh, where did that come from? Anyway, I'm still going to have my hand in the way, aren't I? Let me put it upside down. Oh no, I can do it this way. Okay, here we go. So this is the top, that's the bottom. So if we bend down, you can see weight increases. If we bend up, the weight decreases. Thanks to these wires in here that can measure, I guess, minute changes in resistance as the bar bends both ways. And then that's apparently compared with some calibration data. So I'm not sure if I'm going to be able to fix this because unless, I don't know if there's any way to reset the calibration data or something, or because to me it looks pretty, I don't know, it looks fine to me, but it's still, You know, we could zero it. It seems better now that it's out, but it's still jumping all over the place, even though, yeah. So I don't know if I'm going to be able to fix it, because I don't want to pull this apart to see what it's like, because, well, I could probably do some measurements on the sensors here. That's what I was going to do. Dun, dun, dun. Let's see if I can measure something on there. So we look at I just checked. So we've got, it's about 50 hertz. So I think pretty much all the pads are the same. So it's like we're sampling maybe at 50 hertz, 50 times a second perhaps we're sampling. That's what that could be. Very tiny voltages. So yeah, if I'm not going to be able to fix this, I might as well just pull it all apart, shall we? Okay, I've undone the tabs on the back, which is holding, so it's probably zebra strips, won't it be, to run the display. So this is just the frame around the display. Oops, yeah. The piezo is melted on, so we could probably chop that off, get that off. Okay, it's got two places there. One, two. Okay. The piezo come off now. Yep, there we go. So we can see a bit better. That, I assume, is maybe the heart of the operation. Let's have a look. Can we see what it is? I could probably see what it is. Stand by. Okay, so that's just a quad op amp, LM324DG. But there is a 256 byte or 2 kilobit EEPROM, so electrically erasable EEPROM. So for this one here, so it's a K24C02. So I assume that's got the calibration data. So we've got 3 address pins, A0, A1, A2. We've got a ground, we've got VCC, we've got a write protect pin, we've got a serial clock and a serial data, SCL and SDA. Sorry. Okay, so that actually is an LM324DG, so it's a quad op amp. Okay, so just amplifying signals, blah, blah, blah. But this here is a K24C02, 256 byte, 2 kilobit electrically erasable PROM, EEPROM. So it's got, I think, 3 address pins, ground, VCC, write protect pin, and serial clock, SCL, and serial data, SDA. So I might be able to dump that. But yeah, so I'm guessing maybe under the LCD is where all the interesting stuff happens. So I might still pull. I'm just worried about getting the LCD off, and it's not going to work nicely anymore. Let's give it a try anyway. So there, I assume, yeah, you can see the zebra strip. So, and zebra strip on the other side. So I just want to, I think the whole thing's going to come off, unfortunately. Don't want to crack the glass, do I? Yeah, zebra strip's coming off. Yeah, alright, so zebra strip's still attached to the panel by the looks of it. It's come off the board, so maybe that's alright. That twisted around enough. I think so. Here we go. So that would be the backlight wiring, I guess, power. Damage the zebra strip too much. There we go. Yep, there we go. Okay. So I could desolder the zebra. Okay, so a big blob hiding everything. Surprise, surprise. So I wonder. Okay, so I guess a lot of pins going in. Just wondering what I can actually measure. Let me disconnect all of this stuff. Okay, so now there is some crud on there, so I might clean that off. Just wondering how I'm supposed to test it now. Actually, now that I've disconnected, well, I've still got the power supply. Yeah, all right. Let me just clean this up a bit and see what I can do. So maybe this is turning into be something more interesting. Well, it's more interesting for me than I thought it was originally going to be. But just because I'm just looking at the sensors, so we've got sensor. Okay. Sensor plus and sensor minus. So we've got sensor plus is the white, sensor minus is the blue. And then for each one we've got a capacitor. I think it goes to ground, but obviously there's no capacitor there at the moment. If we look at, I think I was looking at the blue one. So the blue one goes up to this set of resistors. And then these resistors go over to these jumpers here. And we've got jumper 1 through 5. So jumper 1 and 4 obviously aren't in use, but jumper 2 and 3 are set. So if you look at jumper 1, I think it comes, obviously it's not in use because we're not using this capacitor here. And then jumper 2, I think that was right. Oh no, hang on. Jumper 1 comes over there. I was looking at this through the loop, so I don't know if the loop helps. Let's see. We need to get the focus again. I'm trying to do this all one-handed. Oh, that's actually makes it quite easy, doesn't it? There we go. So jumper 2 is the third one from the bottom. So it goes over to that resistor there. Doesn't it? Yep. Sorry, I can't point it out. And then jumper 3, which is also set. 1, 2, 3, 4. Fourth from the bottom. Goes along over to the second one. And then we've got the other two resistors. Oh, hang on. Okay, jumper 1 at the bottom. Oh, okay, yeah, okay. So it goes to those 4 resistors. And then we've got... Right, okay, so it must be some sort of calibration depending on what transducer beam or something that they use. So jumper 1 goes to this resistor, jumper 2 goes to this resistor, jumper 3 to that one, and jumper 4 goes to that one. So that's from this one here. So we've got a common rail there, but we're only using these 2 resistors here. We go back again, let's have a look again. Oh, that makes it so much easier. And then jumper 5 is used to either connect Goes up to there. So that's the EEPROM there. That's the EEPROM there. Top right, I think, is VCC. That's all going off. Then we've got serial clock, serial data. Oh no, write protect. And we've got serial clock and serial data. And we've got the address pins on the other side, which look to be all set to ground. So we'll set to 0 perhaps. So there's only one one address used, one bit of serial data used. That looks right, doesn't it? So it looks like, so these are the address pins and ground. So it looks like they're all grounded. So we're only just using one byte in here. I guess that's all we need. One byte for calibration. And then we've got VCC there. Then we've got, this is the hardware write protect pin. And then we've got serial clock, I think, and serial data. And they go off to the blob over here. Okay, so that was the temperature probe there. That's the op amp there. That's the speaker there. Interesting. So that was for sensor minus. So sensor plus, which is the white wire, I guess, is these ones here. Can we have a look again? I don't know if we can. What can we see? There we go. Oh, so the white one. Sorry, that's better, isn't it? There we go. So the white wire goes to the capacitor there. I don't know if it touches. Does it touch that resistor at all? I'll have to find out. But obviously that capacitor's not there. But yeah, so it looks like maybe sensor plus goes just to here. That one's not connected. So obviously with pads we can solder something on there to check out, more easily measure what's going on. So it's changes in resistance. All right, I might have a fiddle and see if I can find anything interesting. I decided to have a look what was actually in the, was it torsion beam or transducer beam? So it looks like we've got 3 connections. I'm assuming we've got voltage plus and minus, and then we've got sensor plus or sensor minus. So we've got sensor plus on one side, sensor minus on the other side, and then voltage to both. And then we've got this tiny little, let me see if I can leave it like that. Let me find my loop again. I should find some other way. I should get a proper macro lens. I used to have some proper macro lenses. There we go. So it's a bit of a mess. But hopefully you can see it. There's some very fine, get the focus right, very fine grid. Well, it's not a grid, it's lines on either side. So that would be obviously measuring the difference in the resistance, I guess. I don't know if I can, let's see if I can turn this up a bit. That's probably a bit better. You can probably, stop moving. There we go, how about that? Try and get it right. So I have damaged it a little bit. But it's basically well, it's not a grid, but yeah, some lines. So as the metal bends very, very slightly, we get very small differences in resistance. So that's how it works. So, and then on the EEPROM here, we've got all the address pins are grounded. So we've only got basically 1 byte, I assume, or 1 bit. No, it's 8-bit. So it's got basically 1 byte. So which I guess is the calibration data. based on what comes in on the sensors via this resistor array. So we've got some jumper settings there to, I guess, maybe depending on the type of transducer beam perhaps that they use. Yeah, so we've got 1 byte there stored in there. So, you know, I could have maybe found out what the byte was and then adjusted it, adjust it until I get maybe 0. Maybe that's how to recalibrate it, I don't know. Or I could just go to the shops and just buy a new one for 30 bucks or however much these are. So, yeah, I don't know, I might fiddle with this a bit more, I don't know. But obviously I've damaged one side of the transducer beam. So I do have the other side, so sensor plus and sensor minus. I'm not sure which is which. But, oh, anyway, maybe that was interesting. I don't know. If it wasn't, sorry. If it was, I'm glad. Back to computers tomorrow. I'm going to finish off the Husky. I need to finish off the Husky keyboard. Okay. Bye for now.